Hey y'all, in this lesson, we're going to be looking at half-angle identities for trig functions. You should see on the screen our identities that we're going to be using today. So if you have a running sheet of identities and theorems, I would definitely add these to that sheet. Or if you have to memorize them, then go ahead and start memorizing. All right, we have our half-angle identities for sine, cosine, and tangent. I did put some in there that are like likewise, and basically that's where if you square both sides, it gets rid of the square root. Just simple algebra. The tangent one is down there. I've got some different versions of it, if you will. So let's use these identities to find the exact value of these functions. We've got cosine of 112.5. That is definitely not something that we know off the top of our head. But if I multiplied it by 2, that would put me at 225. And that one is on the unit circle. So I can rewrite this using our half-angle identity, 225 over 2, because 225 over 2 is 112.5. And the half-angle for cosine is plus or minus square root of 1 plus cosine of the angle, 1 plus cosine 225 over 2. Make sure. Yes. Nope, that's sine. There it is. And then we can simplify. 225 is in the third quadrant, so it's going to be negative. And the cosine of 225 is negative square root 2 over 2. Which means on the inside of the square root, I'm going to have to do some simplifying. So I'm going to get common denominator in the numerator. We have 2 over 2 for 1. And then join that together. Divide by 2. If we flip 2 over 1 to be 1/2 and multiply it by the numerator, I will now have negative square root of 2 minus root 2 over 4. Then I can simplify the denominator. The square root of 4 is just 2. So in the numerator, I kind of have this yucky thing. In the denominator, I just have a 2. Some people write that with the negative root 2 first underneath the square root. You can switch that around if you want to, but it's technically the same thing. All right, for the next one, we have sine of 105. If we double that, we get 210. That's a 10. And 210 is on the unit circle. So now I can use my half-angle identity. We have, where is it? Up here. 1 minus cosine of the angle over 2, square root of. Okay. Equals plus or minus 1 minus cosine 210 over 2. And then now we need to simplify, decide positive, negative, simplify cosine 210. Go ahead, pause it, try it, come back. Before we move on, I misspoke a little bit earlier. When I was looking at this problem, I realized it. I said that this one was negative because 225 was in the negative quadrant, which is true, but we're supposed to focus on this angle here for the sine of the function. So I'm very sorry about that. 112.5 is still in the negative quadrant for cosine, so it's still negative. I just misspoke there. So for this one, when we're deciding positive, negative, we're looking at 105. So sorry about that. For this one, 105 puts it in the second quadrant, and in the second quadrant sign is positive. So we're going to be using positive for this one. And then we have the cosine of 210 is negative root 3 over 2, and then over 2. We're going to do some simplifying. Minus negative is a positive. We're going to get a common denominator and simplify. We end up with the square root of 2 plus square root 3 over 2, all over 2. Flip it and multiply, then simplify a little bit further. I'm going to switch these like I mentioned on the previous example. Square root of 4 is 2, and that's your answer. Kind of yucky, but that's your answer. Okay, last one here, tangent of 7 pi over 8. Remember, this represents half. So to go the other way, you would multiply by 2 to figure out the one we need. So go ahead and pause it, try it, come back. That's going to get you to 7 pi over 4. So if we use our formula above, I'm going to do sine of 7 pi over 4 over 1 plus cosine of 7 pi over 4. And then we're going to have to take into consideration the positive negative sign of sine or cosine of 7 pi over 4 based on the unit circle. We do know it's going to be root 2 over 2 because of that pi over 4, but now you need to decide if it's positive or negative. Go ahead and pause it, try it, come back, simplify as much as you can. You should have found that the sine of 7 pi over 4, that puts us in the fourth quadrant. So sine is going to be negative and cosine is going to be positive. So sine of 7 pi over 4 is negative root 2 over 2, and cosine of 7 pi over 4 is positive root 2 over 2. We're going to simplify in the denominator here. Negative root 2 over 2 over, that's going to be 2 over 2. And then if we add, we get that. Now flip it and multiply. The 2's would divide. I'm trying to do it in my head. Hopefully I don't get it messed up. And then this ends up in the bottom. Uh-oh. Now we're going to have to rationalize the denominator. But that is okay because we can do it. Remember, we have to use conjugates. And the conjugate of 2 plus root 2 is 2 minus root 2 on the top and the bottom. I might run out of room here. We'll see. We'll see if I can do it. I hate squeezing stuff in like that. We've got negative 2 root 2 plus 2 over 4 minus 2 root 2 plus 2 root 2 minus square root 4 is minus 2. Oh, that worked out. So we have negative 2 root 2 plus 2, so many 2's, over 2. Then we can simplify the 2's out here to be, final answer, negative square root 2 plus 1. That turned out nicely. As always, it gets ugly in the middle and then it turns out. All right, so that's how you do those. You multiply the inside angle by 2. That gives you the one that you'll have in the numerator, and then apply your identities. Last problem here, rewrite cosine 8x all squared using a half angle identity. This looks like a little bit of a challenge, but I promise you it's not that bad. So pause it, think about it, and try it. I want you to try it. It's going to help you learn. Since we're talking about half angle, that means we're actually going to do the opposite. We're going to multiply by 2 because 8x is representing the half. So it's actually going to be 16x over 2 and then all squared. I'm going to go up to my identities and I can see that the half angle squared equals 1 plus cosine x over 2. I'm going to go down here. This is going to equal 1 plus cosine x over 2. And we can't really do cosine 16x. We're just going to leave it as cosine 16x because I don't have what x equals, so we're just going to leave it. You can write it this way, or you can split it up into two fractions. 1/2 plus cosine 16x over 2, or even more, 1/2 plus 1/2 times cosine 16x. So you won't end up with a nice, neat answer like we did in the previous examples. You will have that 16x in your answer, but that's okay. That's just what it looks like. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.